Here is the basic idea of a cooling system, no matter what its mechanism is. Air flows into the unit, it gets cold by some method or another, and cold air blows out of the unit. So it comes in warm, it goes out cold, and it gets blown around into the rooms where people are. We measure the capacity of a refrigeration unit or a heat pump or anything like that, pardon me, in tons. And this is left over from the old days in the 19th and early 20th century when we actually used blocks of ice, often from frozen rivers, to do refrigeration. So there was a whole profession of people whose job it was to saw blocks of ice in the winter, store them, and then deliver them in the summer. The measure of cooling, called 1 ton, is the amount of heat that is absorbed when melting 1 ton of ice at 32 degrees Fahrenheit in exactly 24 hours. And so at 32 degrees Fahrenheit, that's the temperature right at which the state changes from solid ice to liquid water. And right at that point, the ice is melting. This is what a ton means. The amount of heat to melt a ton of ice at 32 degrees in 24 hours. When we're doing cooling of buildings, there are 4 basic processes we can use. Refrigeration in a classic air conditioning system uses refrigerant, and we call it vapor compression. It's got an evaporator and a condenser, basic refrigerator. There's a refrigeration system that actually uses heat to do the cooling. That's called an absorption system. It uses heat, believe it or not. Evaporative cooling, well, you know, evaporation is the principle behind refrigeration. Think swamp cooler. Cooling towers on top of buildings use evaporation. And then, especially in green buildings, there are passive cooling methods called natural ventilation. And there's another class called sustainable building systems that you can take where we learn about how those systems work. In a cooling system, a heat pump or an air conditioner or a chiller, these systems use fluids. And refrigerant is a fluid. It changes state from liquid to gas and from gas to liquid again. And then in a cooling tower or other evaporative system, the fluid is a water, and it's evaporating. In a chiller, we use refrigerant to make the water cold, but then the water that is now chilled flows around through stuff. Let's look quickly at the refrigeration cycle. And this is the same cycle whether you are talking about a refrigerator or an air conditioner or a heat pump. It works the same. And it's based on the idea that when a fluid changes state, it either absorbs heat or releases heat. So this is a kind of potential heat called latent heat. Latent heat is the heat energy involved when something changes state. In a refrigeration system, when liquid evaporates and turns to gas, it absorbs heat out of wherever. When gas condenses and changes back to a liquid, it gives off heat. And think about the heat exchanger on the back of your refrigerator. If you put your hands on the fins back there, they feel warm, don't they? And why is that? It's because that refrigerant has condensed back to a liquid. That liquid is flowing through the evaporator coils behind your refrigerator, and it's giving off heat. And where did that heat come from? It was taken out of the food inside your refrigerator. Well, an air conditioner works exactly the same way. They all have an evaporator in which liquid refrigerant evaporates, changes to gas, and it absorbs heat out of the air. And they all have a condenser where the gas condenses back into a liquid, and when it does, it gives off heat. So there are two different kinds of systems that use refrigerant. This one with the air conditioner and the refrigeration cycle with the heat pump is the vapor compression cycle. The other one that actually uses heat is the absorption cycle. So I find this really interesting, that you can put a flame under a system with refrigerant in it and make something cold. That is the basis of an absorption system. And you might think, oh, well, that is unheard of, until you think about something like an RV, a recreational vehicle. You know how those things have propane refrigerators? Well, I don't know if you know, but they do. They have refrigerators that run on propane. And you might think, well, how does that make sense? How that makes sense is that is an absorption unit. So it uses the heat from the flame, the propane flame, to drive this refrigerant cycle, evaporating and condensing. It's quite interesting. Here are some commercial scale absorption cycle units. They're pretty big. Just a few words about refrigerant, which is used in air conditioners, chillers, heat pumps, and so forth. So there's a numbering system. ASHRAE writes the standard for these numbers, and they all start with R. R something. R stands for refrigerant. And then there's a number, which originally was from DuPont, because they were the people who first made refrigerant. Now everybody uses those numbers. And you might be aware that some decades ago, there was what they call an ozone hole, the protective ozone layer that keeps ultraviolet radiation out of the earth, got thin and developed a hole down near Antarctica. And scientists from around the world got together and figured out that what was causing that was chlorofluorocarbons, mostly from refrigerant, also from things like spray propellant in spray paint cans and hairspray and stuff like that. So the countries of the world got together and formed this Montreal Protocol, and they agreed to phase out CFCs. A standard refrigerant that you found back then was R12. The trade name was Freon. That was a CFC refrigerant, and this treaty dictated that we phase that out and use other refrigerants. I knew some HVAC people back then, and they were really concerned because a lot of systems were using Freon. But now we have, it's been fine, and we have phased into other kinds of CFCs that have hydrogen in them, hydrofluorocarbons. R22 is one kind of refrigerant. R123 and 134A is another kind. This GWP stands for global warming potential. So R22 has one of around 1700. Some refrigerants have 14,800. Let's go see what that means. So you are aware, no doubt, that carbon dioxide being released into the air is raising the average global temperature. It does that through a process called the greenhouse effect. And in the sustainable buildings class, if you take that class, we talk about how that mechanism works. So you can measure the global warming potential of other kinds of greenhouse gases relative to carbon dioxide. So if carbon dioxide has a carbon dioxide equivalent of 1, because it is carbon dioxide, methane, like is released from landfills and sewage plants, if you compare the amounts in the atmosphere over a 20-year period, methane has 72 times the global warming potential of carbon dioxide. Well, that's pretty scary. especially since permafrost, permafrost is frozen methane, and as permafrost melts, it releases methane into the atmosphere, so we're kind of worried about that. Anyway, look at refrigerant R22. Over a 22-year period, it has 5,160 times the global warming potential of carbon dioxide, which is 1. And this is why all commercial buildings have protocols for checking their refrigerant systems for leaks and monitoring, making sure this R22 or other kinds do not escape into the air. There are certain ways that if you're changing out the refrigerant, you do things to make sure that it doesn't escape into the air as you're changing. So refrigerant is behind air conditioning systems and heat pumps.